Alright, good morning and welcome to Chapter 11, Switch Security Configuration. So, it should be a little bit more interesting than the last chapter, which was all the theory. So, this one we'll be talking about how we can configure the switch to mitigate the threats that we discussed in Chapter 10. So, from this perspective, it's a little bit more interesting, although still a fair bit to get through. So, port security, easiest way to secure ports is if they're not in use, shut them down. It's really that simple. If they're shut down, there's no threat that they pose. So, step one, only use the ports that you need to use. Shut the others down. So, the next step to take is limiting the number of MAC addresses that can connect to any given port. So as we know, we generally dynamically learn the MAC address on the port, and what we can do is tell it that, okay, we can only learn 1 or 2 MAC addresses per port, and what that will enable us to do is to stipulate what devices can connect to that switch port, which means somebody can't just randomly come up, unplug an authorized device and plug their own in. So this helps secure the number of devices accessible. So if we have a IP phone and a desktop, there's our 2 devices, 2 MAC addresses, done. Somebody unplugs something and plugs something else in, it won't recognize it. Okay, so it won't authorize connectivity because the MAC address doesn't meet the 2 that have already been placed into the register, and it won't talk to the others. So it's a little interesting. So to start off with, we need to turn security on. So this is switch port security, and this enables the many different layers of port security that we can use. Now, be careful. It is a layered approach. So you have to turn on these options in order. Okay? They may have changed that in the latest security updates to the operating system, but yeah, there was many a time that I've seen people come unstuck because of the order that they tried to instigate port security. Like they would want an advanced function but forget to put the basic ones in. So it wouldn't work because it's a layered approach to security when we're talking port security. So port security needs to be on an access mode port. Alright, so by default our ports are dynamic. They can be either a trunking port or an access port. So when we want to instigate port security, we need to kick it into access mode and then apply the port security. As you can see on the bottom of the slide, the command structure is go to the interface, switch port mode access, and then switch port security, and we have turn security on. Now, this is only step 1 by enabling it. Now we need to add the features that we want. Alright, so first thing we can do is introduce the command to verify that the security is on, and we do that with a show command, show port security and the interface that we want to confirm. So here, the important things we have is it's enabled. On violation, the port shuts down, and the default maximum number of MAC addresses allowed is 1. So if somebody swaps the device out, new MAC address appears and the port gets shut down. Now this shutdown is error disabled, which means we have to manually go in and shut the port down and shut it. So we have to manually shut it and then flick it back up. So it's not a automatic, oh, we'll just wait a couple of seconds and then reactivate the port. No, it needs the command shutdown and no shutdown to reactivate the port, because the port is disabled. So what things can we add to port security? Well, aging commands, MAC addresses, so we can actually specify the MAC address. We can change the maximum number of secure addresses, so how many MAC addresses are allowed, and what to do in violation. Okay, the default you saw is maximum 1, violation, shutdown. So just like with every other command, you can use the question mark to get help as you go through. And the maximum number of MAC addresses is 8,192. Why you'd want that many MAC addresses on a port, I don't know, but that's the range. So you can clearly see there that there's quite a bit of scope for devices to be exchanged, and it's very easy for us to set a value for the maximum number of MAC addresses. As I said, if you've got an IP phone, you definitely need to increase that to at least 2. And what you want to do after you increase the maximum number of addresses is to enable sticky mode. Now what sticky mode does is it adds a line to the config that is basically manually specifying the MAC addresses in the config. And when you save the running config with after it's linked these MAC addresses, when it powers back on, it doesn't have to dynamically learn those MAC addresses. It's already in the config which the authorized MAC addresses are. So people can't bypass port security by going, okay, we'll just turn the power off, plug our devices in, turning the power back on. Because of the sticky feature, it remembers what the authorized MAC addresses were, and that's a permanent set of addresses. Okay, so what does this look like for us in reality? So when you configure, in this case, in the example, it's saying a maximum of 4 addresses, and it's saying I'm going to have a maximum of 4, and then I'm going to statically assign one address, which is AAAB123, and then I'm going to add MAC address sticky. So what it's done here is it's configured manually one MAC address as already authorized. We can now add another 3 devices to this port, and it'll dynamically add them to that. And because it's got sticky, it enters this line automatically. So it's quite a powerful little command structure. And each time you add a new MAC address in, it dynamically updates and adds a new line saying port security MAC address and the MAC address of the new MAC address that it's just found, up to the limit of 4 MAC addresses. Okay, aging. This is how long our secure addresses are valid for. So when the age limit hits, if we haven't seen that MAC address renew, it gets deleted. It ages out, just like the MAC addresses in the MAC address table. Okay, they're only valid for 5 minutes. So after 5 minutes, if they don't see them again, they get deleted. So this is the same mechanism. So at a time, the address is inactive if it's absolute. Okay, so absolute means if I set it for 5 days, it deletes it. Inactivity is like the MAC address table. So if it's not active for a certain amount of time, then it'll get removed. So it's quite a versatile point, in that if we know that we have a fairly regular turnover of devices, like when we have hot desk arrangements with people with laptops and things like that, mobile devices, we want to age this out with inactivity, because we know people are coming and going to the office, so we don't want them consuming all the available authorized ports on that device. So we can put it in as inactivity, and we can have it renew on a regular basis. Now, where do we see where it's in? Well, it's not highlighted here, it's under the highlight. So, age time. Alright, so what is it? The 4th line down is we've got age time and aging type. So this tells us how long the timer is set for, 10 minutes, and the aging type is inactivity. Now, if you're having a constant turnover of devices like this, you probably wouldn't turn on sticky, because it doesn't make sense. Alright, sticky only really works for an environment where you've got a pretty secure and fixed deployment, such as a desktop rollout, where you're basically setting up a machine and it's always going to be on that port. That's where it makes sense to use sticky. Where you've got a fluid office environment, like in startups and sales team that are in and out all the time, then it makes more sense to use your aging timers on port security with inactivity as people come and go. Violations. So here we have shutdown, restrict, and protect. Now, as we said, shutdown is pretty rough in that it requires an administrative shutdown and no shutdown to take it out of error disabled mode. So it requires an administrative input. Restrict means we are going to leave the port active, but we're not going to allow it to send information. So we're dropping the packets that arrive, and what this does is it updates the alerts and generates violation counters and things like that. So we have our logs and our monitoring system set to see the changes in violations and syslog messages, and that would send an alarm up to the administrative team saying something's not quite funky. Well, something is funky here, and we need to have a closer look at what's going on. But it won't take proactive measures like the shutdown does. Okay, so the least secure one is protect, drops the packets for the unknown MAC source and keeps it that way until maximum MAC addresses become available. So if you've got a timeout, it'll stay in that protect mode until a drop in the aging occurs. But this one doesn't send any alarm messages up to the monitoring. So no syslog messages. So you are not aware that this is in violation mode. You only know if you actually go in there and look at the actual port itself. So the first mode is the most proactive. It shuts down the port when something's not right. The restrict goes, something's not right. I'm not going to allow you to send information out, and I'm going to alert the monitoring devices that there's something wrong. Third mode just says, no, you're not authorized. I'm going to drop your packets, but I'm not going to tell anybody you're there. So basically the order of preference would be as they were listed: shut down, restrict, and then protect. So how do we change it? Switch port, port security violation, and then the new mode that we want. So restrict. Okay. I can't see any good reason why you would take it down to protect, because at a bare minimum, if something has changed in the network, you want some notification occurring. Otherwise, not much point in having it on. So what you should see on the port with the error disable state going in. So you'll get an error disabled notification, and then you'll get a security violation notification, and then you'll get the usual shutdown notifications. So this is only really good if you have these the console display open at the time. This is why it's important for it to send it out to the syslog messages, and a lot of our monitoring tools will see the alarm, that syslog change status, and send off an alarm for us to have our attention drawn to the fact that the port's been shut down. So when we look at the port, it is now down and down, but it's not administratively down. It's in error disabled mode. So this tells us that something has occurred and that we need to do a manual shutdown and no shutdown command to re-enable it. Now, normally you wouldn't just do that automatically. You'd go find why that occurred. And I can tell you in one instance when I was working at the other college, we had people decide that they wanted to bring their own access point in and plug it into our network. So what would occur is our switch would go into error disabled, shut the port down, and then they would just, oh, why isn't our wireless working now? Oh, well, just plug it into another port. So this student managed to shut down over half the switch ports in one class at night. It was a night class. What was really funny, the way it came about, is our IT support guy that looked after all the switches in the college noticed a rogue access point alarm go off. So they took a stroll because it says, you know, within a couple of meters of where the access point is. And in these particular classrooms, you had windows on 2 of the walls looking into the classroom. So he could stand in the corridor and watch the student activity, plugging in the access point, and he initiate the port security mode. We didn't have port security mode enabled up until that point because we have been telling people how bad it is for you to come in and add access points to a switched secured network. So a policy was implemented after that night, because what he did was opened his laptop, put on port security, and watched him shut down half the switch. Next morning, people were going, oh, we've got an issue here, there's, these ports aren't working. So it was pointed out to them that, yes, well, when you put in a rogue access point into our network, we're going to shut down the ports because that's not an authorized device. You have access to the network as a student from our authorized devices. In other words, the desktops that were there. You are not given access to the internet via your access point that you plug in, because that makes it unsecure. Anybody can gain access to the network, and that wasn't allowed. So there's an example where the alarms, our network monitoring tools, and policies come into play. So how can I ensure that what is going on? So if you go show port security, it'll give you a list of all the ports and what their states are. So it'll tell you what the maximum MAC address count is, what its count is. So if you've got 4 available and 2 registered, that would be the numbers. And then we have the ports in violation and what their action is if they've been deemed to be in violation. So as you can see there, the current count is 0, violation count is 0. That's because nothing's plugged in. Okay, so just be aware there that you can have quite a bit of detail show up using just the show commands. So this example, we have aging timer of 0 minutes with absolute. Port security is enabled and stats secure up. Okay, so maximum number of addresses, total addresses. So there we have maximum number 1, and we have 1 plugged in and registered. So if we have sticky turned on, each time we have a new device plug-in, we'll get this line being added. So this tells us, tells us that this MAC address was entered into the configuration via the sticky command. Alright, so we know it's a dynamically learned MAC address, and it will put these entries in until it hits the maximum count. So again, port security address. So this one is showing us the MAC addresses that it has registered under the port security mode, and it tells us how it was learnt and what port it's associated with. So as we can have 8,000 addresses, that's a lot of addresses that could possibly be displayed in that show command. So VLANs, a lovely next count. So hopping, spoofing our dynamic trunking protocol messages can be one of the ways that we possibly have VLANs being compromised. Introducing a switch that is not authorized with trunking enabled, we could possibly implement new VLANs into the network, and because it's trunking, they can see all the traffic for the other VLANs being brought down the trunk, and they could set up their own catchers and collect information that way. Double tagging or double encapsulation. This kind of takes advantage of potential issues within the hardware of most switches. I don't know of anybody successfully actually doing double tagging, but I'm sure it's probably been done. Okay, so how we take into account the potential threats and how do we mitigate them. So again, if we want to stop that dynamic trunking protocol being exploited, we put our ports into either trunk or access mode manually, and that way the dynamic trunking protocol has no effect on our devices. Alright, so the other way we can really take a forceful approach is, after manually setting each port, is put switch port non-negotiate or no negotiate is the correct word. This tells the port that it is not even to discuss its status with the dynamic trunking protocol. Remember, we should always set the native VLAN. Do not leave it at defaults. When you leave it at defaults, you can have things exploited. DHCP is the next subset. We're about halfway through, so we're not doing too bad time-wise, I don't think. Let me double check. Yep, on track. Alright, so denial of service is quite a common way of starving DHCP. So Gobbler can create this denial of service. It's quite a common tool out there. So what happens is the MAC addresses get overwhelmed because each time we basically send a request, and remember how DHCP works, we get a request, it sends an offer out, and if we just flood it with these requests, it consumes all the addresses up with offers, and it's waiting for a reply. So that could be a problem. So one of the ways we can stop this is by using snooping, which means only certain ports can have messages brought in. So this filters the types of DHCP messages and limits the rate that messages can be transported across those ports. Okay, so we have one of the things you can do is build a table of authorized MAC addresses. Okay, so it's a bit of a problem, but you could do that. So you basically record the MAC addresses and the IP addresses. So you're binding the MAC addresses and the IP addresses together, which is a bit now you can do this in many different ways, but the most common way of doing it is just enabling the snooping in global config and then going into the ports and saying this is a trusted port. Okay, then as I said, you can limit the rate of messages. So what you can do there is say, well, I don't expect these messages to occur faster than this. Now, if it's just a single device on the other end, how many messages do you expect per second? Shouldn't be that many, yeah? So you can cut this down if it's a trunking port where you've got an IP helper happening and you're forwarding messages onto the server in a different VLAN, for example. Then what you would have to do is do a combination, work out how many devices would generally be requesting service as it's being forwarded. You know, if all the devices turn at once, you want to be able to cater for legitimate traffic and not limit it. You know, like if the building lost its power, all your devices would come up the same sort of period. So you may need to do a bit of a calculation on maximum speeds or messages per second that you would expect under the adverse effects. So there's that. So what's it look like when we turn it on? So IP DHCP snooping and global config. Then you go into the interface and you put snooping trust on, and then on the snooping limit, so rate 6, so you're saying between these ports, on each of these ports, because you've used the interface range command, we have a limit of 6 messages per second coming in from any of those ports. Okay, but in this example here, we have the DHCP server sitting on Fast Ethernet 1. This is why we're saying it's trusted, because this is where our server is. So we're going to trust that the server is not connected to this port. So if a server suddenly pops up on port 20, we know it's not a trusted source, so it'll be ignored. We then stipulate the snooping on the VLAN numbers so that we're actually looking on the VLAN tags. So if we suddenly have DHCP coming in on a port that or VLAN we haven't said is trusted, then we know that something's going on and to set off alarms. So how do we verify it? Show IP DHCP snooping and show IP DHCP snooping binding. So between these two commands, we'll get a list of information about the configuration, and the second one, the binding one, will tell us what IP addresses have been assigned to the MAC addresses, and will tell us how much least time has remaining, which VLAN and port it came in on. Whereas the snooping command is our summary. So it tells us what VLANs we're snooping on. Okay. Tells us what ports are trusted or untrusted. So the status tells us what is happening. In other words, are we going to trust the DHCP messages or not? And how many packets per second can travel through this port? So how many messages per second can we have? ARP attacks. Remember what the ARP table is? It's our MAC address table. So we've talked about this in the last chapter. Dynamic ARP inspection was our method to mitigate this, and here we see that it relies on DHCP snooping being enabled. Okay, so remember I said port security is a layered approach. We need to build up the features to get to the advanced ones. So to have ARP inspection, we need snooping, vice versa. So just be aware of that. You can't just go, okay, I want snooping. Okay, want snooping. That's fine. But remember, snooping, you need port security turned on first. So you need to stipulate the maximum and the violations and things like that. Now, we can just put port security on and leave it at defaults. That's fine, but it's got to be on. Those features are running. Then you can apply snooping. Then we can apply our dynamic ARP inspection. But we can't just go dynamic ARP inspection by itself. You've got to have the other two features enabled before that will happen. So this basically says I'm going to intercept all of our ARP requests and replies, and I'm going to inspect that the IP and MAC addresses are correct, and I'm going to drop and log any replies coming from invalid addresses. And if I get too many of these, I'm going to error disable the port to stop this attack. So here we go. We have our trusted ports and untrusted ports. So remember, we turned on global. So here we have our trusted port being the router. The router is going to be our DHCP server or our helper. So basically, to get to the DHCP server, we're going via the router in this instance, whether the router itself is our server or it's a pass-through with the helper command. So we have snooping enabled, and then we turn on ARP inspection for the particular VLANs that we want. So this tells us what interfaces are trusted, what ports are trusted, and we now have the situation where we basically should have all our access points as untrusted ports. And you go, well, hang on, we trust our devices. Yes, we trust our devices, but we don't trust people not to add their own devices. Cybersecurity, you are, how to say this politely, you have to be a paranoid individual. Now, that's not saying you have an issue with your mental health. This is just the reality of it. You have to think that somebody is out to get you all the time. That's the sad reality of cybersecurity now. If you don't take that paranoid approach of thinking somebody's always out to get access to the network, you won't protect the network effectively. So, by assuming every port's not trusted that faces an access, okay, because you've seen how easy it is to plug a device into a socket. You just sit down at a desk and reach over and there's your port, plug it in, boom, job done. You now have access to the network. So these settings that we are enabling is based on the fact that somebody is doing the wrong thing. And sadly, from personal experience, I can say that you're always going to have somebody that thinks they're entitled to do something to the corporate network because they think they have the same rights to that as if they were at home. People forget it is not their network and they need to comply with policies, because people are people. And as you get older, you'll come to understand what I'm saying there. So how do we mitigate this? We go through the DHCP snooping configuration and we put the trust on, and then we put in our ARP inspection commands. So IP DHCP snooping turning on globally, saying we're snooping VLAN 10, and we're going to now add our inspection to VLAN 10 as well. So we IP ARP inspection VLAN 10. Then when we go to our trusted interface, put IP snooping on trust, and then we put ARP inspection trust as well. So this is telling the device that we trust the information coming from our trusted source. So not to take error disabling modes within that port, because that's a trusted source of our ARP and our DHCP. So let it flow through. The other access ports where somebody could easily plug in a new device and do impersonation attacks and so on from, we're not going to blindly trust these ports. We're going to trust them as far as we can comfortably throw them, which is never very far. So basically these ports are a risk, so therefore we can't trust them because they're open to anybody. Okay, your trusted ports are hidden behind locked doors with restricted access physically to them, whereas your user ports are out on everybody's desks with unrestricted access. This is the problem. Anybody can gain access to the access ports. So this is why we don't trust them. So what do we look at? We can look at the destination source MAC addresses. Okay, remember that the headers are able for reading. So we've got the frame and headers. Well, it's not quite frame. We're not looking at an Ethernet frame. We're looking at the ARP messages and the DHCP messages. So we're looking at the different sections in the headers. So we're looking at the MAC address because an ARP request is working at layer 2. Remember, it sent out a request saying I'm looking for the MAC address of a given IP address, and it sent that out as a broadcast, but it expects a unicast coming back saying this is my MAC address and that is my IP address. So it has those fields available to it in the ARP header. So this is what we can inspect and make decisions on. So we can validate these source, destination, and IP addresses. So we can have multiple validate commands, up to 3 of them, because there's 3 options. So we can validate the source address, the destination address, and the IP address. So they're the 3 options. We can validate 1 or all 3 of them. We just have to repeat the command each time. So that command is IP ARP inspection validate, and then what we're going to validate afterwards. We can only have 1 option specified per line of config. So as we can see here in the example on the screen, we need to enter 3 lines in the config to get 3 options validating. You can have 1 or all. 1, 2 or 3 options, or none. Okay, so you don't need to validate, or you can just validate the source, or you can validate the destination. It's up to you what you want to do. Now, depending on the version of operating system, remember, over the years, things get expanded. So if you have the latest and greatest operating system, you should be able to stack those commands one after the other on a single line. All right. When in doubt, when you've got a mixture of very old equipment and very new equipment, do the lines individually. That way you know that they're all going to work. Just as a heads up. Next, and our final segment will be mitigating. Yes, I'm going a little stir crazy. Spanning tree protocol. So this is where we're talking about our guards. Remember, spanning tree uses bridge protocol data units to flood the system to find out if there's any loops. And one of the things we stated was the issue with ports taking over 30 seconds to initiate under standard spanning tree. So we wanted to bring those ports up to a forwarding state straight away so that the DHCP service could be used. So we did that by putting the port into a PortFast mode, which bypassed blocking and listening and learning states. So we're expecting just to have a PC or another device plugged in. We definitely don't want another switch plugged into that port, because that would cause a loop and that would be bad. So we enable our PDU guard, which throws the port into an error disable state if a PDU arrives on the port that is in PortFast mode. Now, PortFast and BPDU guard should only be on end device ports. So devices that connect to laptops, PCs, okay, not to other switches. Anything that could have a trunk, we don't want PortFast occurring on. So configure our PortFast on access ports only. So you do the switch port mode, access, spanning tree, PortFast, and you'll get a lot of messages coming up saying, oh, this is bad, and this could cause all sorts of trouble, bridging loops, use with caution, And what you want to do is only have it on those interfaces you want it on. So you can have it as a default setting. So spanning tree PortFast default is a global setting on the switch rather than going into each. Now, if you're not having trunks, fine. But I would rather you use the range command rather than the default one, because the chances of you having a switch without a trunk configured these days is getting lower and lower. So I would recommend you use your range command. So when you're entering your interface range and turning all your ports into access mode ports, I would put the spanning tree PortFast command as a range. Because, as I said, most switches you will have some trunking happening. So I do not recommend using the default option. Show running config begin span will give you a summary of the config file beginning at spanning tree, and the show spanning tree summary command will give you a summary of all the instances of spanning tree running on your device. To confirm whether PortFast is enabled, you need to do the look at the interface itself. So you can do this via the running config or the spanning tree interface and the detail subset. So you look at your specific interface and type in detail, and that will give you extra details about the config of spanning tree on that interface. So what's that look like when we configure guards? Alright, so we go into our interface and we put spanning tree PDU guard enable. Now we can put this on by default by putting in spanning tree PortFast PDU guard default. That means wherever we have PortFast enabled, we're going to have the guard enabled by default. That is a good way of using a default value so that any port that is in PortFast will have the guard setting. Now, what happens if we hit a PDU coming in to our PortFast? It'll go into an error disable state, and we can actually have a automatic reset for that state. So the command error disable recovery calls port secure violation, and we can tell it to reset itself, and we tend to give it a time. Okay, so it goes into error disabled, and then we have a timer saying stay in that error disabled mode until we recover for X amount of time. And what this does is it tells us the port shutdown, our logging takes over, see the alarm, but it changes back after a given time. So it sets off the alarm and re-forwards back to PortFast. Now, this is not necessarily the best way, but if you've got end devices and you got idiots just plugging things in, like we had with our night students at an old college I worked for, this recovery could be set to an amount of time, like in 5 minutes, just auto recover, and that way the administrator wouldn't have to manually go in and reset all the ports, and the switch would be available fully for the next class. That's the benefit of having the auto recovery. Alright, so strangely enough, being a config chapter, there's going to be labs and packet tracer activities for you to do. Again, try to do them, if time permitting, because these are what cements the command structures into your brain. Okay, if you're innocent like me, you learn by doing. So by doing the packet traces and lab activities, you can actually try to remember them, which will make doing the chapter tests easier because you'll remember via the keyboard. So all interfaces on a switch should be secured in a production environment. By default, remember the ports are dynamic auto trunking, so they have the ability to form trunks on every port. So you really want to turn that dynamic trunking protocol off. Turn off unused ports, that way they can't be used to hack your system. If you're having MAC addresses limited and learned dynamically, we should use the sticky command, and that will enter those MAC addresses in to the config so they stay with it long term. One of the other things you can do is set up how your port behaves if it gets an error. So we can have it disabled, or we can have no traffic being resent, but notification sent, or just blocking. Okay. Then we had a quick look at how to mitigate dynamic trunking protocol and the problems that it uses or has within that protocol. We should not use it. We should have it set manually to access points or trunk ports with no negotiation enabled. So that way the issues with the trunking protocol are overcome by the fact we're not using it. We then had a look at the issues with DHCP and the fact that we want to set our trusted ports. In other words, this is the port where the server resides, that's going to be trusted. Everything else is basically not so much trusted, and what we want to see is messages coming in on the various VLANs, but we want to limit the frequency of those messages from those ports so that we don't get a flood of messages hitting our server, effectively denying us of our DHCP service. Another thing we can add to that is our ARP inspection, and this has to have DHCP snooping enabled for us to do the deep inspections required of ARP to prevent exploitation of ARP protocol. So within that we can have our trusted ports. Again, we're going to trust where we have trust for DHCP. We trust the ARP information from coming from that source. The others we want to inspect and decide what to do with. So lastly, we looked at spanning tree and the fact that PortFast and bridge PDUs shouldn't come in to those access ports that we expect end devices to reside. So we looked at how we can automatically assign PDU guard status to any port that has PortFast mode enabled. So that way, if somebody plugs in a rogue switch, it would automatically error disable the port so that they cannot create a switching loop, which is bad for broadcast storms. So we can protect our switching fabric from excessive traffic being generated with no way of stopping it. And that brings us to a very long and drawn out chapter 11, which is port configuration of port security. Where's the off button? There it is.